of aviation started with Leonardo da Vinci. His sketchbooks from the 1500s were filled with concepts of flying machines with bird-like wings in hopes that they would enable the people to fly. In 1655, Robert Hooke contradicted da Vinci's theory, saying that the human body was incapable of flight by artificial wings. In 1783, Joseph and Etienne Montgolfier flew not with wings, but in the first manned hot air balloon, and 10 days later, Professor Jacques Charles flew in the first gas balloon. In 1843, William Samuel Hanson designed a steam engine-powered monoplane, but this design was flawed as it was too heavy to fly. Sir George Cayley, now known as the father of aerial navigation, spent years researching kite-shaped wings to support heavier-than-air aircraft. In 1852, he built the first successful flying model and tested the first full-size man-carrying aircraft. Around 1985, Otto Lilienthal proved the practicality of powered flight in heavier-than-air aircraft. And in 1903, Wilbur and Orville Wright, commonly known as the Wright brothers, conducted countless experiments, designed their own biplane, and flew a total of 98 seconds in 4 flights. Hundreds of thousands of hours of research have brought us the knowledge about aviation that we have today. Taking into account the structure of the aircraft and the concepts of aerodynamics, we now know that 4 forces, thrust, lift, weight, and drag, act upon an aircraft in straight and level unaccelerated flight. Thrust is the forward force produced by the power plant and propeller. Lift is the upward force which is produced by the dynamic effect of the air acting on the wing. Drag is a rearward force, and is caused by disruption of airflow by the wing, fuselage, and other protruding objects. And weight is the combined load of the airplane itself, the crew, the fuel, and the cargo or baggage. Weight pulls the airplane downward because of the force of gravity. An aircraft has 3 axes, all intersecting through its center of gravity. Controlling the aircraft involves moving it along each axis. The longitudinal or roll axis passes through the aircraft from nose to tail. The lateral or pitch axis passes through the aircraft from wingtip to wingtip, and the vertical or yaw axis passes through the aircraft vertically. The center of gravity of an object is defined as the point in which the weight of a body or system may be considered to act. An aircraft balances on and moves around its own center of gravity. The position of the center of gravity determines the stability of the aircraft, as the center of gravity moves toward the tail of the aircraft and becomes more unstable. To be able to fly, an aircraft, mostly airplanes, have 5 major components. The first one is the fuselage. The fuselage is the body of an aircraft. It is designed to accommodate crew, cargo, and passengers. It is also where the wings and tail of the plane are attached, and it may be constructed using a truss, monocoque, or semi-monocoque structure. A truss structure fuselage is built with welded tubing known as longerons to form a braced framework. Additional struts are attached to this structure to resist stress, though this design does not have a streamlined shape and is less aerodynamic. A monocoque structure uses stressed skin instead of an open framework to support loads and external forces, though there is still a chance of surface deformation. This type of construction is more lightweight and spacious as there is no need for an internal framework. The semi-monocoque structure is most common for aluminum planes. Similar to the monocoque structure, it uses stressed skin to support all loads. However, the semi-monocoque structure has additional stringers aside from the bulkhead and formers to reinforce the external skin. The wings are attached to either side of the fuselage and are the main source of support and lift that enable planes to fly. Different types of planes also have different wing designs depending on what the aircraft is used for. Airplanes can also have multiple sets of wings. Planes with one set are called monoplanes, while planes with 2 sets of wings are called biplanes. Wings also have different structures. A semi-cantilever design is supported by external braces or struts, while a full cantilever is not. The basic internal structure of the wing also has 3 principal parts. The first one is the ribs, which determine the shape and thickness of the wing. The second one is the spars, which carry the weight of the wings while on the ground. And the third one is the stringers, which are attached to the ribs and support the loads and stresses of the wings. The external structure of the wing has moving control surfaces on the rear part. The ailerons are attached from the wing tips and extend to about half of the wing and move in the opposite directions to enable the airplane to roll. The flaps are attached from the midpoint of the wing, where the aileron ends, to the fuselage and move downward to increase lifting force of takeoff and landing. The empennage or tail of the plane consists of the vertical and horizontal stabilizers as well as the movable control surfaces. The rudder, which is attached to the back of the vertical stabilizer, is used to move the nose of the airplane left and right. The elevators, attached to the back of the horizontal stabilizers, are used to move the nose of the plane up and down. The rudder and the elevators may also have trim tabs attached, which are used to reduce control pressures. Trim tabs may also be installed on the ailerons of the wings. The landing gear supports the plane when it is parked. It also enables the plane to move on the ground while taxiing, taking off, or landing. Wheels are the most common landing gear, but some planes can also have flows for water or skis for snow. And lastly, the power plant is what enables the airplane to move forward. It consists of the engine, which provides power, and the propeller, which uses that power to turn and generate thrust for the aircraft. There are 4 theories in the production of lift. The first 3 are Newton's basic laws of motion. The first law states that an object at rest stays at rest, and an object in motion stays in motion, with the same speed and in the same direction unless acted upon by an unbalanced force. A parked aircraft will stay in the same place unless a strong enough force such as its own engine power is applied. A moving aircraft will be kept moving by inertia while other acting forces, such as the change in flow of wind around the control surfaces, may cause the aircraft to accelerate, decelerate, or change direction. Newton's second law. Force is equal to change in momentum per change in time. For a constant mass, force equals mass times acceleration. These are the factors involved in overcoming the first law, such as changes in direction and speed, including acceleration and deceleration. Lastly, Newton's third law states that for every action, there is an equal and opposite reaction. An example of this is when the propeller pushes air backward. The air pushes the airplane forward with equal force. And the last theory is Bernoulli's principle of differential pressure. As the velocity of a liquid or gas increases, pressure decreases. When air passes over the curved top of an airplane wing, it increases velocity. This decreases pressure, which generates lift. The chord line is a straight line connecting the leading and trailing edge of an airfoil. It is the line joining the endpoints of the mean camber lines. The mean camber line is the locus of all points equidistant from the top and bottom of the airfoil. The leading edge is the most forward point of the mean camber line, and the trailing edge is the most rearward point of the mean camber line. An airfoil is a structure with curved surfaces designed to give the most favorable ratio of lift to drag in flight. These are the structures of a plane, such as the wings. Air moves downwards when it hits the lower surface of a wing. This causes an opposite upward reaction or lift for the wing. When air hits the upper surface of the wing, it would initially push the wing downward. However, due to the shape of the airfoil, the air is still pushed downwards, which again generates lift. Airfoils are designed to create low pressure above, high pressure below. The airfoil is angled and the top surface is more curved than the bottom, so that air above moves faster than the air below. More speed above equals less pressure above, which creates lift.